Welcome to EDU World Space.
Alright, so to answer part A, let's start by taking a look at the equation Q over the potential is equal to A constant, times the permittivity of free space over D. So now if we rearrange the equation to solve for Q, we get that it's equal to VA, the permittivity, over D. So now, since we know all these constants, all we need to do is just substitute the values straight from the question. So if you do that and compute it in our calculator, actually here, let me go ahead and write it out for you. 25 volts times 0.03 meters and times 8 point, let me write the 8 a little bit clearer there. 8 times 8.85, sorry, 8.85 times 10 to the negative 12 over 5 times 10 to the negative 3. Now, if you compute this in our calculator, we're going to get that it's equal to 3.98 times 10 to the negative 11 coulombs. So therefore, the required charge is equal to this. And that's the answer to part A. So now moving on to part B. So the electric field can be defined by this equation over here. So E is equal to potential over the distance. So since we know the potential and we know the distance, all we need to do is just plug it right into this equation. So 25 over 5 times 10 to the negative 3. And now if we compute this, we're going to get that the required electric field between the plates is equal to, that's just to the power of negative 3. Yeah, so the required electric field strength between the plates is 5 times 10 to the power 3 volts per meter. Now moving on to part C. So the kinetic energy of the electron between the plates can be expressed by the standard equation for kinetic energy, which is equal to 1/2 mv squared. And we also know that when the electron is ejected from the negative plate, then its potential energy is equal to its kinetic energy. So its kinetic energy is also equal to the potential, which can be written as the potential times the electron charge. Let's just write that as E. And if you substitute the standard equation for kinetic energy, which is 1/2 mv squared, then we have set ourselves an expression to which we can solve for the velocity. So if you solve for the velocity here, remember this is potential, not velocity, but this is velocity. So if you solve for a velocity by isolating this variable, we're going to get that's 2ve over m, and this whole thing is in a square root because velocity squared. So now if you substitute the values that we have, so it's 2 times the potential, which is 25 volts, times the charge of an electron, which is 1.6 times 10 to the negative 19, over the mass of the electron, which is also standard, and 9.11 times 10 to the negative 31 kgs. And now if you compute this, we're going to get that the velocity, the required speed of the electron, is equal to 2.96 times 10 to the 6 meters per second. And that's it for this question. Thank you for listening.